Piecewise defined functions. We saw a function here, and that's all we had. If I asked you, well, look at this function, do you see any breaks in that function? No, you see no breaks at all. Things go really smooth. This is what we call continuous function. We'll adjust this next one. A piecewise defined function, you can define it to be piecewise, continuous, but more often than not, a piecewise defined function is not continuous. What does piecewise mean? If someone asks you, what would you tell them?
Maybe the variables function which certain parts that were broken off from each other.
Exactly.
There are exemptions.
So think of it this way: you have pieces of thread, and you tie them together. So you have 10 pieces. You tie them together. You got a long piece of thread. But is it continuous? No, it's got a whole bunch of stuff in the middle. So that's what we call piecewise function. You're stitching together multiple pieces to form one function. The pieces matter. Good. How many pieces do we have? 3. Okay. In algebra, we have a name for this, the set of all x values. Okay. The domain. I think we will cover this later also. The domain. The corresponding y values would be the range. So we have defined the domain for each piece. And there are 3 different domains, and writing it this way has a name. Start with the letter I. I will agree to it. Yeah, sure. Inequality is okay. How about this? This has a name.
Interval.
Interval, right? This is an interval. Of course, the expression is an inequality. I cannot deny that answer. But in reference to a function, that is an interval. So in this class, or in general, we never put an equal sign close to negative infinity or positive infinity, period. There is no equal sign here, but there is one there. So what does it mean? It simply means when I evaluate x is equal to 1, I will pick the second piece, but not the first, because 1 is included in the second piece. Now tell me, if I want to evaluate it at x is equal to 4, would I use the second piece or the third? Third piece, because x is equal to 4, it's right there. And I want to see 3 pieces. when we get to chapter 2, we will encounter something called limits. Limits are related to derivatives, calculus. So the best way to understand limits is you would understand it better if you can understand piecewise defined functions really well. So for all values of x less than 1, so 1 is right here. What is the value of 1? 2. So I'm going to draw a line at 2. Should I include that 1?
No.
We've agreed that we shouldn't. So I'm going to put an open dot. It simply means it's not included, that value. Now we have the second piece. Second piece, when x is equal to 1, what is the value of y? 2. Well, was open, but when I evaluate it at 1, what has happened? It takes on the value 2, it gets closed because of the second piece. Does that make sense? And as I plug in other values, when x is 2, I'll get 3. When x is 3, I'll get 4. When x is 4, I'll get 5. But should I put an open or closed dot?
Open.
Open. Many reasons why I didn't become an artist. I can't even draw a line properly. Third piece. When x is equal to 4 and greater than 4, what is the value of y? 2. And it's going to start at 2. Should we include here?
Yeah.
Yes. And it is going to keep on going. Okay, so sometimes, the thread example that I used, as you tie the knots, you still took the pieces and connected them together to form one piece, right? Same argument here. We were lucky, or I designed the problem in such a way, initially the first piece produced an open dot, but the second piece came in, filled that open dot. Happened here. Did it happen there? No. So one's going up there, the other is down here, and clearly there is a jump. That jump means a break. Do we agree? So piecewise defined functions, you can make them to be continuous, but oftentimes, or more often than not, they're always discontinuous. I am going to let you try one before we move on to next topic. Okay, so what through people all believe is that negative x and x. Now, with practice, you'll know exactly what that is. I know what those functions are. So negative x, x, 1, and 2, those are the pieces. These two are easy, right? But you're stuck because you don't know what that looks like, on that interval, less than or equal to -3. So first, I'm going to plug in y equals negative x. Yes? Hit graph. I get an idea already. But I want to limit the values between, some small value all the way up to -3. So go back to window. -10 is fine. The maximum has to be -3 because we stop at -3. Good. So the graph should be it's going down. And where does it stop? Stops exactly at 3. And should that be a closed dot or an open dot? Closed, equal sign there. I'll graph it over there also. The next piece. The next piece is defined between -3 and +3. We want to know what y equals x looks like. So I'm going to replace -x by +x. Let's go ahead and adjust the window. I want it between -3 and +3. Good. So it is a line that goes that way, and what is the maximum value it's reaching? 3, and over here, -3. Should it be closed on both sides or open on both sides? Open, because no equal sign, no equal sign. That's the second piece. Good. That's good enough for now, because the other pieces are easy. So we know the picture from the calculator. -x looks like that, and that y value is 3. For this piece, the y value there was at -3. And what was that y value? +3. These two are quite easy. So if you have difficulties or looking at the x values piece by piece, you can do what I did earlier. Piece 1, right? -infinity all the way up to -3. Piece 2. Where should I draw the next dotted line? 5. And about 5, right? So piece 1. And that would be 2. Easier way to look at things. So I know piece 1, things are coming down this way and stops at +3. So dot that shape that way. The second piece between -3 and +3, At -3, we have the value of -3. Open door, decided there. +3, I have +3. And we draw a line, because that's what the calculator gave us. Between 3 and 5, which is the third piece, when x is 3, I'm including the value of x, so when x is equal to 3, what is the value of y? 1. Putting a close dot. And when we're going all the way up to 5, and it stays at 1, but should it be a closed dot or open dot at 5? Open. And when x is equal to 5, we have to look at the last piece. And when x is equal to 5, what is the value of y? 2. Closed dot or open dot? Closed. And from that point onward, it keeps on going. Now, in algebra or whatnot, they'd say put an arrow indicating it just goes that way and that way. As you get to upper level math, you kind of get lazy. You don't put arrows.